All right, today we are diving into one of the biggest questions in all of science. And the answer, believe it or not, comes from a concept that sounds super complicated, but is actually this beautiful universe-creating flaw. It's called CP violation, and it's pretty much the only reason we're even here to talk about it.
I mean, it all boils down to the most fundamental question you can ask, right? Why is there anything? Why do we have a universe packed with stars and planets and, well, us, instead of just an empty void of energy?
So the problem really starts at the very beginning, at the Big Bang. Our best understanding tells us that the birth of the universe should have created matter, that's us, and its perfect mirror image, antimatter, in exactly equal amounts. But here's the catch. Whenever matter and antimatter touch, they completely annihilate each other in a flash of pure energy. So if everything was perfectly balanced at the start, it should have led to a perfectly balanced destruction, leaving behind a universe with nothing in it, just light.
And yet, here we are. We're living in a cosmos that is made almost entirely of matter. The annihilation, it wasn't total. Somehow, in that first epic cosmic battle, matter had this tiny, almost unnoticeable advantage. Something, somewhere, cheated.
So, to figure out how matter pulled off this cosmic heist, we have to zoom way, way in. We gotta go from the scale of the universe all the way down to the subatomic world. We need to take a close look at the fundamental rules everything is supposed to follow, the rules of symmetry.
Okay, so the first rule is called parity symmetry, or just p-symmetry for short. The easiest way to think about it is with a mirror. Imagine any physical process, like a particle decaying. Now imagine watching that same decay in a mirror. P-symmetry says that the mirror version should be just as possible, and it should happen just as often as the real one. For a long time, physicists just assumed the laws of physics didn't have a preferred handedness.
And then you've got the second rule, charge symmetry, or C-symmetry. This one says that if you take any interaction and just swap every particle with its opposite charged twin, like an electron for a positron, the laws of physics should work in exactly the same way. So you put these two ideas together, and they paint this picture of a perfectly balanced, symmetrical universe.
For a long, long time, these symmetries were basically considered sacred, unbreakable laws of nature. But then, right around the mid-20th century, that perfect, mirrored view of our universe, well, it started to show some serious cracks.
It all started with a simple question from two physicists, Tsung-Dao Lee and Chen-Ning Yang. They were looking at all the data and had a realization. Sure, these symmetries had been proven for forces like electromagnetism, but nobody had ever actually tested if parity symmetry held true for the weak nuclear force, the force that's responsible for radioactive decay.
So an experiment was set up, led by the absolutely brilliant physicist Chien-Shiung Wu. Her team watched the decay of cobalt-60 atoms, and the results were a total bombshell. The decay was not symmetrical. It turns out the universe does play favorites. Its mirror image was flawed. Parity was officially broken.
Now this was a massive shock to the physics community. But physicists are a clever bunch. They thought, okay, maybe p-symmetry is broken on its own and maybe c-symmetry is broken on its own, but what if we combine them? What if the universe's true mirror isn't just a reflection, but a reflection where you also swap every particle for its antiparticle? They called this new combined rule CP symmetry, and for a little while it seemed like order had been restored.
But that new, patched-up rule, well, it wasn't going to last. The hunt for a perfect, unbreakable symmetry was about to lead to an even more profound discovery, the one that would finally point us to the solution of our big cosmic mystery. I mean, look how fast all this happened. In 1956, boom, parity's broken. Just 1 year later, in 57, CP symmetry is proposed as the big fix. But then came 1964, and two physicists, James Cronin and Val Fitch, were about to discover something that changed everything all over again.
They were studying these weird little particles called neutral cons. And what they found was that these particles and their antiparticle twins, they didn't decay in a perfectly symmetrical way. Even when you did the mirror reflection and the charge swap, there was still this tiny but absolutely undeniable imbalance. Even the combined CP symmetry was broken.
And this wasn't some small, obscure finding. No way. This was a fundamental crack in the very foundation of physics. It was so important that in 1980, Cronin and Fitch won the Nobel Prize for it. They had found the universe's built-in cheat code.
So, what on earth does the decay of some tiny, obscure particle have to do with the entire universe? Well, it turns out, everything.
This little glitch wasn't some mistake in the cosmic machine. It was a feature. It was the crucial clue to why any of us exist at all.
Think about it like a recipe for making a universe. You start with perfectly equal amounts of matter and antimatter. But to get the universe we see today, you need a secret ingredient. You need some process, some law of physics that treats matter and antimatter just a little bit differently. That's the only way you can end up with a tiny surplus of matter that survives the big annihilation event.
And that is the answer. The CP violation that Cronin and Fitch discovered back in 1964 is that secret ingredient. It is the fundamental asymmetry baked into the laws of nature that allowed matter to win the cosmic war against antimatter.
I mean, the implications of this are they're staggering. It means that our reality, everything we see, our entire existence, isn't the product of perfect, symmetrical, elegant laws. It's the leftover result of a flaw.
And isn't that just incredible? The answer to the biggest question we could possibly ask, why are we here, wasn't found by looking at galaxies or stars, but by studying the bizarre behavior of some of the smallest things in existence. The grandest mystery of all was solved with the tiniest clue imaginable.
So let's just wrap this all up. The universe started with a rule that should have guaranteed its own destruction, but a tiny, beautiful asymmetry, a violation of the combined laws of charge and parity, broke that rule. For every billion matter-antimatter pairs that wiped each other out, this tiny flaw let just one extra particle of matter survive. And from those survivors, everything was built. The Earth, the Sun, you, me, the whole shebang.
So we're left with this really profound thought. Our universe isn't perfect. It exists because of a glitch, a fortunate flaw in its fundamental design. And it really makes you wonder, doesn't it? What other incredible secrets about our reality are hiding out there, not in the perfection of the laws, but in their beautiful imperfections?